Recently, I had a post where I talked about the hardware selections that I had made for the roof tracking system for my observatory project. I did a little bit more work, and as a result of that, I found some alternative selections, which I ended up going with. I've now ordered them. They've showed up. I have them in hand, and I thought I'd take a few minutes just to go over what I ended up getting. The original track I was going to go with was aluminum track, but in my post on galvanic corrosion, I decided I wanted to move away from that. So I ended up finding this V-track, which is galvanized steel. It's pretty heavy duty. It's about 12 gauge, 6-foot lengths, and it has holes already mounted for attaching them to the tops of the walls. And these look like they'll work out just fine. First, let's take a look at the V-groove wheels. My original V-groove wheels were a little over 6 inches in diameter, and they were cast iron. They supported about 1,000 pounds each, but they're also going for almost $50 each. And I was going to go with 5 with one extra 6 as a backup. So that had a pretty good budget. But as I did more research, I came across these particular V-groove wheels. Now, these are 3.7-inch diameter wheels, but they're made of steel and they're zinc galvanized for corrosion protection. They have closed bearings on it, and they're rated for 2,200 pounds each. So that's more than double what the other ones were. The other thing that I found very attractive about this is the fact that for $75, I could get 4 of them. So I ended up getting 8. And what I'm going to do, even though I have double the load capacity, you have to keep in mind that the V-groove system that I'm going to use is only on one side, which means any lateral wind forces are going to be dependent on these wheels engaging the V-track to make sure things aren't shifting sideways. So what I've decided to do is, instead of putting 5 on, I'm going to put 7 on, so I have more wheels engaged with the track, and so I'll have, not only a better load capacity, but I'll have a better side load capacity as well. And if you look at how these things engage on this track, they actually fit very nicely. So I think I'm going to have a good engagement, and they're narrow enough that I don't have to worry about the screws that'll be mounted to hold these in. But one thing I didn't like about these is the fact that this bottom plate is about half the width of the ones I was looking at. And since we're worried about lateral forces, I wondered if this was too narrow a mounting point. So we've decided we're going to supplement that, and I'm having some 3x5 by 1/4 inch steel cut. Each plate will have a hole drilled to match this particular pattern. And so when we bolt this to the roof, it'll be going through that plate as well, and that'll help to shore things up and help distribute the side loads. Now, the next thing I wanted to look at is what I was going to do for the flat wheel. And the wheel I was looking for was about $50, but I found these wheels on Amazon. These are 4-inch wheels. They're very heavy duty. They're rated at 1,000 pounds each. They have a nipple in here for grease, so these are open bearings. And they have another one inside the wheel itself, and they have very, very heavy bases in here. These should work out pretty well, and these will be riding on a flat track, which was going to be aluminum, but now is going to be a 3.5-inch wide strip of 3/16 stainless steel. So this will handle downward forces and give a little bit of slop for any alignment issues that might crop up over time. Now, I want my observatory to be automated, which means I need to have a passive interlock system so that when the roof is fully open or fully closed, there are some passive interlocks which engage the roof to the walls so that I have some wind protection. But a lot of the time, the observatory won't be in use, and so I would like to have something that's more secure to attach the roof to the walls. So what I wanted to do is have some manual toggle clamps. that would be put at strategic points at the connection between the walls and the roof. So I found these on Amazon. These are about 40 bucks for a set of 2. They handle a load of 7,700 pounds each. They're very heavy duty, probably the most heavy duty latches that I've seen. The one problem I have with it is this U channel here, which is basically the distance you can adjust to span what you're trying to bridge across, is too short. Obviously, if my wheels here are 6 inches high, I need to be able to span the difference between this, the track, the walls, and the roof. So I'm going to need a U-shaped part here, which is much longer. Fortunately, Rick Albrecht, my mechanical engineering wizard friend, has offered to help me with that. He's going to buy some heavier duty steel rod. We're going to make it longer. We're going to bend it into the same exact shape. Then we'll tap it so that we can put screws on the bottom just like this. And now the distance between the bottom and the top can be greater, and we'll span the wheels, and we'll still be able to clamp the roof back to the wall system. The other thing I picked up is hardware that I'm going to be using in order to attach these parts to the observatory itself. I've got some long galvanized bolts that will attach the V-track to the top of the wall and yet still clear the wheels. I have some stainless steel longer screws that will allow me to take the stainless steel track that I'm going to have for the flat track and attach that. And I have some other screws of different sizes that are either galvanized or stainless that'll let me attach different things to different places. I don't have all my hardware yet. I still have to get some attachment hardware for the mounts. As you can see, the holes here are pretty heavy duty, and so these will have to be bolted or lagged into the walls, and also I'll need some heavy bolts for that, but I haven't gotten those yet. But I'm starting to get the critical hardware that will be compatible for my needs and should work out great. In the background here, my friend Gary Villa took my logo and cut some sheets of aluminum. There's 3 layers of this that lets me I can paint each layer a different color and sandwich it together to create, or I should say recreate, my logo. And my plan is to get these painted, and then I'm going to mount this on the outside of the observatory with another plaque that will be the formal name of the observatory. That name has not yet been determined, so I haven't made that yet. And I'm finding that to be a bit of a challenge. I have a whole bunch of ideas, but I can't say there's one that really resonates with me yet, so that search continues. And with this, I now have most of what I need in order to support the build of the observatory. The only thing I still have to do is get the motor system, which is going to be an interactive astronomy sky roof system. And I'll be talking more about that in the future. So that's all for today. This is kind of a short one, but thanks for spending some time with me, and we're one step closer to having the observatory project come together. As always, I appreciate your comments and feedback. And with that, this is Pat Cosgrove for Cosgrove's Cosmos, signing off and wishing you clear skies and excellent seeing.